Welcome to the abnormal distribution. My name is Sehr, and today we will be learning about multinomial coefficients, which is how to count the number of ways objects can be arranged in multiple categories. Now, you may have heard of binomial coefficients denoted as n choose k, but multinomial coefficients handle scenarios with multiple possibilities. Let's look at the definition. Assume that n1, n2, all the way to nk are positive integers of identical objects where n1 plus n2 plus towards nk equals n total objects. Then the multinomial coefficient is n choose n1 towards nk, which equals n factorial divided by the product of n1 factorial times n2 factorial all the way to nk factorial. You may also think of this as the product of multiple binomial coefficients, which is a special case where k equals 2. So you may write it as n choose k, which is the same as n factorial divided by the product of k factorial times n minus k factorial. Let's do an example. A florist wants to make a bouquet of 5 roses, 3 tulips, and 2 daisies. What is the total number of unique arrangements the florist can make? Now, our first step is to classify our givens and find n. So we have 5 roses, 3 tulips, and 2 daisies, and their sum is 10 total flowers. Let's allocate 10 spots respectively. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I have 10 spots, and I would like to allocate 5 roses in any of those spots. So 10 choose 5 is our first component. Now 10 minus 5 is 5, so I have 5 spots left to allocate the rest of my flowers, and I would like to allocate my tulips first. So 5 choose 3 is our second component. And 5 minus 3 is 2, so I have 2 spots left for my leftover flowers, which are the 2 daisies. So 2 choose 2 is my last component. Using our formula, let's convert this into an equation. We have 10 factorial divided by 5 factorial. 10 minus 5 is 5, so 5 factorial times 5 factorial divided by 3 factorial. 5 minus 3 is 2 factorial times 2 factorial divided by 2 factorial. 2 minus 2 is 0, so 0 factorial. We can cancel out like terms like the 5 factorial here and here, and the 2 factorial here and here, and the 0 factorial simply becomes 1. So after simplifying, you're left with 10 factorial divided by 5 factorial times 3 factorial times 2 factorial, which gives a total of 2,520 unique ways. Let's do another example. How many unique arrangements can you make with the word statistics? So let's classify our n terms first. N1 will be our s's, and we have 1, 2, 3 of those. N2 will be our t's, and we have 1, 2, 3 of those. N3 will be our a, and we only have 1 a. N4 will be our i's, and we have 2 i's. And N5 will be our c, and we only have 1 c. So if you add them up, our total is 10 letters, which will be our n. So following the formula here, we're going to place 10 factorial in the numerator, and then our denominator will follow down the list. So we're going to have 3 factorial times 3 factorial times 1 factorial times 2 factorial times 1 factorial, and calculating that gives us 50,400 unique ways to arrange the word statistics. And this is how you calculate multinomial coefficients. Thank you so much for watching, and stay curious.